Very good. Okay, guys, welcome to this session about civil and environmental engineering. My name is Costantino Manes. I'm an associate professor here at PoliTo. I'm here to tell you what civil and environmental engineering is about. Here at PoliTo, the course is in English. So to be consistent with the language of the course, I'll be speaking in English, okay? The aim of this talk is to try to explore in a sort of funny way, as funny as possible, as enjoyable as possible, what this discipline is all about. And the aim is really to send you this message. Civil and environmental engineering are essentially is a degree that merges together two engineering courses. One is civil engineering, and the other one is environmental engineering, of course. The reason why we decided to launch this new course is that the two disciplines can no longer be studied independently. Any problem in civil engineering requires an environmental analysis. There is no way we can work in civil engineering without assessing and mitigating the impact of whatever we are designing on the environment. Okay, this is a requirement for many problems pertaining to the area of civil engineering. Okay, so what I'm going to do now is to share my screen and share with you a little presentation I prepared to have fun a little bit together. It's like a quiz we're going to do together. And please, can you please use your phone to connect to kahoot.com, this site, and soon I'll be giving you a number, a code that you can use to start playing with me. The idea is that through a series of simple questions, we will explore what civil and environmental engineers do in their career, which problems they have to face, meaning you'll have a taste of what you're going to study. And rather than looking at the list of exams with some weird names, I thought that doing some quiz to get some questions together was a little bit more fun. Maybe I'm wrong. So we have Victor, Gracie, GD, anybody else? JT, very good. One missing, probably. Let's wait for a couple of minutes in case someone watching, streaming, may actually join. Okay, apparently not. So we can start. Civil and environmental engineering. Now, before we go into the hardcore of the questions, I've prepared for you. Tell me a little bit about you, okay? Let's get to know each other. So I'm going to ask you a couple of questions. And then at the end of this little seminar, I'm going to ask you the same questions and see if I've done my job properly. First question for you, it's not a quiz, it's a poll, is this one. How confident are you about enrolling in civil and environmental engineering? Totally. Very, but I would like to gather more info. Not much, but let's give it a go. No way, can I leave? Which one is yours? Okay, the good news is that nobody said, no way, can I leave, which is a good start. Most of you said, not much, but let's give it a go. And one of you is very interested. Okay. Slightly different question. So, how confident are you about enrolling in a civil and environmental engineering program at PoliTo here? Totally very, not much. No way I'm going elsewhere. Okay, same stuff. Very good. That seems consistent. So let's see. Maybe at the end of this talk, I will have only green answers. Who knows? Let's see. Okay, let's talk about civil and environmental engineering. What the heck is a civil and environmental engineer? Well, as the title suggests, we have a civil engineering part. And the stereotype of a civil engineer is a one doing structures, designing structures, okay? And that's true. The civil and engineering program retains the core of the, the soul, let's say, of the core of a civil engineering program, which is a lot about designing structures. And if I may say, what characterizes really a civil engineering is that civil engineer is able to design enormous structures. It's the scale of the problem that makes it different from, I don't know, a mechanical engineer. Mechanical engineer will never build, I don't know, a dam or a big bridge or a skyscraper. This stuff is hundreds of meters tall, okay? So clearly, whenever a civil engineer has to deal with these sorts of problems, starts asking questions like, so which material should I use? Is that concrete? Is it steel? And what are the forces acting on my structures? Should I care about wind, snow? Should I care about the weight of people and things I put at each floor? Should I care about earthquakes? Clearly in Italy, you have to. Big problem. So these are the typical questions that are addressed, especially by a special kind of civil engineer, which is the structural civil engineer. So civil engineering, as a stereotype, deals with structures. And that is true. It's a very important topic of civil engineering. Now, just to play, tell me, what is the loading that is more important for the structural design of a skyscraper, in your opinion? Is it the wind loading? Is it the earthquakes that we really have to be careful about? Is it the weight of people and objects at each floor? I don't know, the weight of snow. Since it's so tall, maybe it's always snowing up there. Wind loading and earthquakes got most of the answers. That's correct. Wind loading in big skyscrapers is the main concern. Not, of course, because of the intensity of the loading, but not only. Whenever you have the wind hitting a slender surface, you start generating turbulence, vortices, that makes the structure oscillates at frequencies that are quite dangerous. So a civil engineer is very good at modeling, understanding, predicting the behavior, the dynamics, okay, of structures, things that move under the action of some forces, okay? This is really a core subject of civil engineering, but this is nothing new. Most students I talk to know about this. Perhaps what you don't know is that air is not only a danger for civil engineers. The technology developed so much that now we use air also to build structures in a creative way. And pneumatic structures are quite famous. Think about the Allianz Arena Stadium in Germany. That's a pneumatic structure. And we use these balloons, you know, as canopies to cover things or for doing activities. Now, it is clearly just a game to play together. Which one of these statements do you think is true? So the air inside the balloon is lower than the atmospheric pressure. The air pressure inside the balloon is equal to atmospheric pressure. It does not matter how pressure is distributed. the air pressure inside the balloon is greater than atmospheric pressure. So how should we design a balloon so that it can be used as a structure for civil engineering purposes? And I'll tell you why this is important. The air pressure inside the balloon is greater than atmospheric pressure, of course, otherwise the whole balloon collapses. No question about that. And this is just to tell you that a civil engineer learns a lot, not only about the mechanics of structures, okay? Solid things that move like a skyscraper, okay, under the action of wind. Civil engineers study fluid mechanics. In this case, the fluid is air. It's something you will be studying if you enroll in a civil and environmental engineering program. More than air, though, you will be dealing with the behavior and the dynamics of water. So a very important subject in civil and environmental engineering is hydraulics. You can call it hydrodynamics or fluid mechanics. These are all disciplines that are brothers and sisters, okay? Very similar to each other. And that enters into many problems. Initially, I told you that the design of a skyscraper is the typical job of a civil engineer, and I would say a structural civil engineer, okay? Whenever you design a bridge, and this is a very famous bridge on the River Thames in London, civil engineering really goes at its best in using all the skills, or most of the skills, that a civil engineer acquires during his or her career. A bridge is extremely complicated. It's a marvel. Designing a bridge is no joke. Okay, there is the structure of the bridge that has to hold all the loadings imposed by what? Its own weight. Buses, trams, people passing by, but they are very heavy. The structure has to hold. But then, look at this. A bridge has piers and abutments to hold the structure. Okay? Thank God we have gravity, so everything touches the ground. And most structures, like also skyscraper, have to be designed so that at the interface between the structure and the ground, okay, the ground actually can hold the weight of the structure, or any loading that the structure has to load as well. Hold, not load. So here, bridge, this structure, these pieces of structures that we design that interact with the surrounding ground are called foundations. Okay, and the discipline that is dedicated to the study of foundations and the behavior of rocks, the behavior of soil, the behavior of ground in general is called geotechnics. And it's so important that if you go at study at a master level, you can choose a pathway called geotechnical engineering. Okay? But geotechnics is clearly a discipline that is studied by any civil and environmental engineering programs. Okay? Very important. We will do some more examples of geotechnical problems. Let's keep talking about bridge. This is a bridge over troubled waters, meaning bridge over a river. And intuitively, you would guess that we need to be careful about the river, because the river can be, you know, during a flood, what happens to the river? Grows, correct, in depth. So if the bridge is not designed appropriately in terms of height, it will be flooded. That's not good. The civil and environmental engineer who tells you what is the river depth during a flood is the hydraulic engineer. Hydraulics is a discipline that is very much studied in civil engineering, but it does not tell you only what is the depth during a flood. It tells you what is the velocity of water. And to do that, you will study a lot of fluid mechanics and hydraulics, okay? You will learn how to use mathematical models to predict where the water goes, what is its velocity during a flood, what are the forces it exerts on the piers of a bridge, okay? Now, there are problems also that involve both the structure, the hydraulics, and the geotechnics. Now, let's see. Just a curiosity. During a flood, what is the most frequent cause of bridge collapse? The erosion of sediments around the foundations. You know now what the foundations are. Hydrodynamic loadings on the structure. The loading of winds that during floods are often very strong, or the impact of rocks and debris like trunks on the piers. What is the main cause of bridge collapses? In your opinion, give it a go. Okay, fairly uniform distributed, but there are two correct answers. The erosion of sediments around the foundations. This is something not many people know. Whenever a river hits the piers of a bridge, what results from the interaction between the pier and the current is the generation of turbulence. Turbulence has a lot of power for eroding sediments. And if you remove the sediments from underneath the foundations, simply the bridge has no ground, okay, underneath his feet. So it collapses. In the last 20 years, I've been repeating this many times today, in the last 20 years, in Italy, 150 fluvial bridges collapsed, mainly for this cause. 150. I'm telling you this, well, to play together, but also to tell you that don't get fooled by the idea that civil engineers are only concerned about building and designing new things. That's part of the job. But another part of the job, which is even more challenging, especially in view of the ongoing climate change, is understanding what is the vulnerability of existing structures against extreme events caused by climate change, like floods. In many parts of the world, extreme events are predicted to be more intense and more frequent in the next whatever years, 10, 20, 30. So a big question is, many of these bridges, many of our infrastructures were built in the 80s when we didn't care much about climate change. We did not design these structures to hold, to be resilient. You heard this word, to be resilient against such events. Do we have the resources to rebuild them all? Of course not. We have to be good at identifying those that are really at risk, use all our knowledge to identify those that needs to be reinforced or replaced. And that requires a lot of skill. Okay. I wanted to tell you something, but I forgot, probably not important. So this is the message. Let's keep going. We'll see the scoreboard later on. We talked about bridges. One thing. It's good that I have this slide here. So we talked about geotechnical engineers, civil engineering, let's say, hydraulic engineering, structural engineering. They all belong to the area of civil and environmental engineering. Okay? There is another branch or another discipline that is traditionally studied by civil engineers, and it's transportation engineering. Did you know that? Whenever you study civil and environmental engineering, you study important things like traffic management. This is huge, enormously important. Traffic management is done by using people with great skills in math, because they do network analysis. And transportation engineers are good in identifying the fluxes of goods, of people, to identify the needs, to support decision makers like politicians in whether it's worth investing in building a railway or not, and to implement something that you probably heard a lot in the news recently, which is the sustainable mobility. In the future, we need to minimize the emission of greenhouse gases from cars. We have to minimize pollution because we are drowning in poisonous air. That's not good. The civil engineer will be at the forefront. Actually, this is a topic which is perfect, is civil and environmental engineering. If there is a discipline of environmental engineering that is typical really of environmental engineering, like structures are for civil engineers, environmental engineers deal with pollution. How to estimate emissions of pollutants from industries, from cars, how to treat polluted water or polluted air, okay? This is really the discipline of an environmental engineer. Pollution, and a lot of pollution comes from traffic. So whenever you have these skills about dealing with pollution and you put them with skills about traffic control and management, put them together, you will be the professionals who will deal with sustainable mobility and will make our cities more livable. Out of curiosity, this is a quiz for you. How many cars you think are required in an hour to match the transport capacity of a bus passing by every 10 minutes? A few hundreds cars, a few tens, a few thousands, about 50 cars can match the capacity of a tram passing by every 10 minutes. A tram has a capacity of 200 people, more or less. A car, 4 or 5. Quick, fast. Time's up. Ooh, a few hundreds. I was the correct answer. Nobody got it. If we use public transport, we save 300 cars from hitting each other and emitting a lot of pollution in cities. Easily. That's a sustainable way of moving around. If you decide to take your car and not using public transport, then you have to worry about where to park your car. Let's see this scenario. You park your car next to the slope of mountains. Here in Turin, we have a lot of stunning mountains. There are the Alps around. So you may want to go for a hike somewhere in the mountains. You park near this slope, and there is this big rock leaning on a slope of 27 degrees, having a friction angle of 25, and you worry whether this is going to fall. Okay, when you drive, you probably see the danger signs. Careful, rock falls here. And the typical engineer who deals with assessing the danger of these rock falls and design structures that holds rocks to hit cars or people that stay at the foot of the slope is the civil engineer. Actually, is the environmental or civil engineer, because they both have typically a strong training in geology. You will always have an exam of applied geology and geotechnics. And this will tell you how to assess whether the slope of the mountain is stable or not. Now, in this case, to play a little bit, What do you think is going to happen? The rock slides and hits the man, poor guy. The rock slides and hits the car. The rock tumbles and hits the man. The rock tumbles and hits the car. Or the rock doesn't move. What do you think is going to happen? Okay, so it's 3 and 2. The correct answer is the rock slides and hits the car. Well, why is that? Let's see. Well, the answer is fairly easy. If there is a friction angle of 25 degrees, and here the rock leans on a slope of 27, it means that it will slide. But since it's called center of mass projection on the horizontal projection of the leaning surface is inside it, actually. So it's not going to tumble, it's just going to slide. And it's going to hit the car, which is something you may get intuitively from the sketch. Okay? So this is a big business, assessing the risk of rockfall or of landslides, or even snow avalanches. This is really a topic that environmental engineers and civil engineers are good at. It's one of the topics you will be studying and potentially work on. I worked myself on avalanches, and there were a lot of civil engineering studying that, okay, in a research institute in Switzerland, right? Now, what happens? Unfortunately, the rock fell and hit the car. This slide is entitled, "You need hydraulic engineers to fix your car." That's a bit misleading. Of course, if you want to fix your car, don't go and talk to hydraulic engineers because they have no idea how the car works. However, they helped designing, with their knowledge of fluid mechanics, they helped designing and inventing this thing called hydraulic jacks. Have you ever heard about the hydraulic jacks? I always found it fascinating because it's a very simple machine that allows us to lift very heavy objects like cars through the use of fluid mechanics. I admit I am a fluid mechanicist, so I love this stuff, okay? A car of weight 1,500 kilograms is leaning on surface A1, which is of 15 square meters, enough for a car, on one side of the U-shaped tube. And then on the other side, you have another surface A2 leaning on top of the water. The blue thing here is water, okay? And the A2 area is 0.01 square meters, so it's area of this size. I want to know from you the following. What needs to be placed on plate A2 to hold just enough to hold the car? 2 packs of pasta, 1 kilo. A feather, 1 gram. You need at least 15 kilograms or 1,500 kilograms, which is the weight of the car. Fast, 7, 6, 5. What do you think is the right answer? Correct. You just need a force equivalent to 1 kilo, 2 packs of pasta to lift that car. This is because it's not much about the force we care about, but have you ever heard this concept of pressure? That's what you care. And pressure distributes uniformly over, let's say, horizontal planes. It's not exactly like that, but just to intuitively understand. Okay, so that's the the working principle of hydraulic jacks. And they're all about fluid mechanics, actually fluid statics. I ask my students this question of fluid mechanics, okay? keep going. Now, another thing that environmental engineers and civil engineers are very good at is surveying. You know what that is? Surveying. Surveying is about capturing the world and making a digital copy of it. In the old days, survey engineers would use techniques to represent even a planetary scale, okay, our planet on a map like this one. Nowadays, we can really survey anything with a very high precision. And this is extremely important whenever you want to identify the exact location of a slope of a mountain that is at risk of landslide. You call the survey engineer. Okay, can define exactly the position from a universal reference system, or if you want to build whatever, you want to know that that column has to be there, not half a meter on the left or on the right. It has to be on the right spot. So the skill of an engineer, of a civil and environmental engineer, to tell you how to position things is learned by learning surveying. And one of the first things you learn is about reading a map. You know how to read a map? Okay, let's see. This is a map of the world, okay? You're probably very used to. You have seen this before, right? Based on your knowledge, look at Greenland and look at India. What do you think is true? The surface area of Greenland is the same as India. Greenland is smaller than India. Greenland is way bigger than India. Maps prove that Earth is flat. What do you think is the true answer? The surface area of Greenland is smaller than that of India. Absolutely. Even if in the map it looked a lot larger, that is a distortion due to the fact that we have to take something that is spherical and we have to project it on a plane. And in doing that, there are many ways of doing it. In this way, on the map you have just seen, this projection causes things that are at the extremes to look a lot bigger, even if they are not. Keep in mind that India is probably 30% bigger than Greenland in reality, okay? Big distortion. So maps are a bit old-fashioned, still very important. Nowadays, do surveys, we use a lot satellite technology. Environmental engineers and civil engineers, so civil and environmental engineers will learn about satellite technology, will learn about surveying. You can use it as you want. You can put it on a drone. Many of our students become very skilled with drones. We offer courses on drone driving, okay? Become a pilot, because they're very useful to do surveying. And satellites, so the possibility of using a satellite to locate things is great. It improved and made a lot quicker our surveys. So they're very much used nowadays in engineering. And it's astonishing how the technological advances allowed us to have GPS providing the position in real time with quite high accuracy. Not bad. You're probably used to the GPS in your car or in your phone. Wherever you go, if you don't know where you are in a city, you look at your phone and then you find the right place wherever you want to go. Engineers use it for, locating things and know where we have to build what. Now, so what is the precision of a global positioning system for geolocalization of things in real time, in your opinion? Are we talking about precision of a micrometer, 2-3 millimeters, about 1 meter, or about 2-3 centimeters? Real time means while moving. What do you think? Where did the technology lead to? about 2, 3, oh, it's quite spread, but 2 of you got the right answer, about 2, 3 centimeters. The satellites have 2 or 3 centimeters precision. It's incredible. You know how it works. So whatever receiver or emitter you have sends them a message, a signal that is received by the satellites. Satellite understands what is and goes back and understand what is the distance between the object and the satellite. Knowing the distance, you can build a sphere around the satellite, okay? You do the same with 2 or 3 or more satellites, and you intersect all the spheres, you have 1 point. That's where you are, more or less. That's how it works. And the precision we have now, it's astonishing. This is good. So surveying, very important part of civil and environmental engineering. Definitely something you're going to learn. Now let's talk about something that, in my opinion, I delivered this presentation earlier on. It was lunchtime, so that was perfect. It's not dinner time yet, but let's introduce something that is peculiar of environmental engineering, okay? If you choose to study civil and environmental engineering, you will learn the core subjects of civil engineering and the core subjects of environmental engineering. And we talked about them. We talked about hydraulics, we talked about geotechnics, structural engineering, we talked about pollution for environmental engineering. Sustainability is a topic you will be studying in this course. It's extremely important, very modern science, how to make everything we do sustainable. Why is it important to know it? I challenge you, pick any website of any industry you like. For example, in the food industry, pick anyone. Are you all Italians in here or also from abroad? Okay, keep whatever company you like, Lavazza, Aya, whatever. There will be always a web page in their website dedicated to describe how sustainable they are. And at the moment, I am sure this is a lot for marketing purposes. People care about sustainability. People start caring about the planet. People start caring about climate change. People are now very well aware of pollution. So sustainability is something that is growing and growing and growing in the market, okay? So just to give you an example of what sustainability means, I'm going to ask you, all this traveling made me hungry. I want to eat sustainably, and I choose to eat a burger. Is this a sustainable choice? Why not? There are many reasons, and you are both right. One is farming produces a lot of greenhouse gases, which is a problem. And we need a lot of water to produce 1 kilo of meat. A lot of water. It's astonishing. Water is a problem. Water scarcity is a problem even here in Piedmont. Now we are experiencing a drought that is horrible. So there's not much water around. We cannot waste water. And I'm talking about water, you know, do you know water, what percentage of water is used for? Worldwide, 70% of the water is used for agriculture, to make food, okay? 20% of water is used for industry, processed water is called. And then 10% for us, to have a shower, to cook something, okay? So in agriculture, the bulk of water is used in agriculture. We cannot, and 20% is used in industry. So we cannot really, there's not much water we can use in the planet, and it's used for right purposes, so to give food to us and to give an economy to us. So wasting water is something we should avoid. So quiz for you. What is the volume of water required to produce 150 grams of beef that you have in a burger? Half pint of water, 100 liters, 2,500, 10 liters. What do you think is the amount of water required? Absolutely right. 2,500 liters of water to make something that you eat if you are hungry in what? 5 minutes. A lot of water goes into that. Water resources management is a subject that is typical of the civil and environmental engineering area. Something you will be learning about. How to save water, how to use water sustainably, where can we find water and extract water sustainably without disrupting the ecosystems, and in ways that allow to minimize the waste of water and to produce polluted water, especially for what concerns the industry. Last question for you. After a good burger, we are in Italy, we love coffee, we have a coffee. This is just to tell you, sustainability is pervasive, is in anything, okay? And if you have attended the presentation about environmental engineering, you probably have seen this example, have you? This is a typical example in coffee. Is it more sustainable to make coffee with the mocha or a coffee machine? Yeah, that's a coffee machine from brand. I should have, I don't look at here, okay? What do you think is more sustainable? It is more sustainable to drink coffee from mocha, drink coffee from a machine. Mocha and machine are equally sustainable. Forget about coffee, I want another burger. Who wins? If you have seen the presentation, you cannot answer. You know the answer. Drink coffee from mocha. And two of you, okay, so it's not exactly unanimous. This is correct. I'm glad you got the right answer, most of you, but it's not by, you know, an enormous margin. So as far as CO2 emissions, mocha and coffee machine are more or less the same. Not great difference. In terms of energy, if you include everything, transportation, production of mocha, the energy used to make coffee, all these things, the mocha wins, is more sustainable. For example, for water consumption, the coffee machine is a lot better. But clearly, in terms of waste produced, managing waste is another topic that you study a lot in environmental engineering and in civil and environmental engineering. So I was saying waste, from the waste point of view, clearly a coffee machine has the capsules. So mocha is a little bit more sustainable because the only waste you have is the coffee you use, which can be reused in agriculture, for example, okay? This is just a little game we played, but that I'm eager to show you because it shows 4 problems that are typical in sustainability analysis. Greenhouse gas emissions, energy consumption. We are having big issues about energy. Water consumption and waste. Okay, these are 4 areas of study that are enormous and that are covered in the environmental engineering program. Okay. Guys, I'm done asking questions to you. The quiz is almost, well, the quiz is over. Do you have any question for me? I'm sure one of the questions you may have, what are the job opportunities out of this degree? Don't you have these questions? Yes or no? Well, who cares? Well, clearly, my suggestion is to pick whatever degree you like. Well, whatever degree you choose it because you like it. If you study something you love, it's not studying. It's, well, it's enjoy, you will enjoy it. So that's the very first ingredient. The second one is clearly might be a bit more strategic is, okay, but what am I going to do after graduation? Well, I can tell you, with the civil and environmental degree, first of all, you are entitled of attending both civil engineering courses or environmental engineering courses at the master level. And let me tell you, the job opportunities for civil and environmental engineers out there at the moment are enormous. At the moment, the companies phone us and say, please recommend someone. I need an environmental engineer. I need a civil engineer. I need that. I will keep receiving these questions. All the students that graduated doing their final thesis with me found a job before graduation in the past 6 months. So if you are looking for, for some sort of certainty of having, a salary, a job, a career right after graduation, I can tell you civil and environmental engineering is a good place to be. At the moment, it's marvelous. We have highly demand of civil and environmental engineers. Okay, please. For the master, after, well, you may choose, there are classical civil engineering courses where you may specialize in structural engineering, hydraulic engineering, geotechnical engineering, infrastructures and transport engineering. You may enroll into here in Italy it's called environmental and land engineering, which is environmental engineering. And in there you have a pathway into climate change, into, it's called, in English is called into environmental, an area called, I don't remember the exact name, but an area called about pollution. So water treatment, air treatment, soil treatment, okay. Then there are other pathways related to civil protection and natural risks in environmental engineering. And what else? I'm sure, geoengineering, which is sort of geotechnical engineering, but with a more geological flavor, let's say. So this opens up to all this. I'm talking about Turin. Of course, once you graduate with the civil and environmental engineering, you can go anywhere you want within the remit of this field. If it depends on the curriculum, usually yes, you do. I do have in my courses students from energy engineering, and I teach in the climate change path of environmental engineering. There are, but maybe you have to give one exam just to cover up some disciplines that probably in energetic engineering are not. But this depends from case to case and is assessed by the admission tutors on an individual basis. Okay? You have other questions? Okay, so let's see if I've done my job correctly today. Moment of truth. Tell me a little bit more about you now. How confident after this presentation are you about enrolling in a civil and environmental engineering program at PoliTo? Totally, very, not much. No way, I'm going elsewhere. Yay, very good. Totally and very, but I would like to gather. But that's big improvement. It was all yellow at the beginning. Anyway, guys, thank you very much for your kind attention. I hope to see you all here in PoliTo with us and enjoy the rest of the weekend. And let's get some rest because we are all tired. Okay? Ciao, ciao.